Okay, good evening everyone. Bonsoir à tous et à toutes, and welcome to tonight's presentation of OTF Connects titled The Progression of Division with Carl Pearce. We have a fairly large group tonight with mostly experienced users, and Carl is also very experienced with OTF Connect, so it should all go very smoothly, despite the fact that we are pretty much going to test the limit of the technology tonight with a particularly interactive session. Comme toujours, je voudrais profiter de l'occasion pour souhaiter la bienvenue à nos collègues franco-ontariens. La session est en anglais, mais si vous désirez obtenir des informations par la suite, n'hésitez pas à me contacter. We are definitely thrilled to have each and every one of you with us tonight, and we're also thrilled to welcome Carl Pearce. Carl is a mathematics consultant with the great Essex, sorry, the wrong slide. I'm going to go back there, sorry about that. He's a mathematics consultant with the Greater Essex County School Board, where he's developing all kinds of new creative ways to spark students' curiosity using online tools that are particularly visual and quite fun to use. He also shares his work by leading professional development seminars, both in mathematics and in the effective use of technology. He's also an Apple educator as well as trainer. You can learn a lot more about Carl by visiting his website. I'm going to paste that in the chat box. Here it is. His website is called tapsintoteensmind.com. Carl is also active working on a few other OTF projects. And at this point, without further ado, I'm going to invite Carl to actually start the presentation by, perfectly, thanks Carl, by loading the application sharing screen. And go ahead with application sharing. Thanks, Carl.
Awesome. Thank you, Michelle. I appreciate the warm welcome, and it's always great doing these sessions with you as the moderator. I am excited to continue our journey from our progression of multiplication that we explored last month. And now we're going to be diving into a little bit of division. But don't worry if you weren't at the last session. We will try to uncover some of those pieces as we go along the way. So as I see in my browser window, I'm at khmath.com, and I'm loading up a game show. I always try to make this as interactive as possible. So if you have a mobile device with a camera, definitely head to khmath.com/play. You should see that in your chat currently. And there's a game pin, Guru2447. We'll get you signed in as a guest. And when we get started with our first task, that will allow us to really be interactive. And ultimately, what we're trying to do with that tool is to give you the power to take photos of your thinking or screenshots if you're going to be using some of the interactive tools that I'll share with you this evening as well. So let's get ourselves started here. First up, so here's our game show link again. Once again, that is in the chat box. Once you get logged in, you'll notice that it's going to ask you for that course code. So it's up on the screen again, also in the chat box. And you're simply going to pick an avatar, type in a name as a guest, and you're going to join the game show. This is the icon that you're going to be looking for when you want to share your thinking. So by clicking on that, once you submit a solution, you'll be able to upload a photo of your work, and I'll be able to share that to the screen. I'll pull that into our presentation. So let's get ourselves going. A little bit about myself for those who are new to these OTF Connects with myself as a presenter. I'm from Bell River, Ontario, so I was that guy way at the bottom left-hand tip of Ontario, right across from Detroit. This is my first year as a K-12 math consultant for my district. However, I've been doing an instructional coaching role and teaching role for parts of the last 10 years with that district. So quite a number of things that I'm involved in, as Michelle mentioned, with OTF, currently involved in the NORCAM project, and another project, the Global Math Project. So something that you definitely want to take a look at by going to Global Math Project on the web, and hopefully we'll see you and your class involved this coming October for Math Week. So as we get started here, I see a hand is up. Oh, it looks like maybe it went back down. So if you do have any questions, feel free to toss your hand up and turn your mic on, or toss them in the chat, and we'll do our best to help you out. But first, I want to talk a little bit about my vision for mathematics, and that's that we want to try to start all of our learning with some context by making the tasks visual and as concrete as possible. We're going to talk a little bit tonight about concreteness stating and how that might factor into division, and then how the math is interconnected. And I feel that if we can do these things, we're going to change students' perceptions about math. We're going to increase their confidence, and finally, we're going to see their student achievement improve and increase over time. So what we're going to do to get started tonight is we're going to jump right into a task. So in order to do so, I'm going to go ahead and hit the play button on Game Show. So I see 19 of you are logged into the Game Show window. I'm going to paste the link to the video in the chat, just in case you're not in the Game Show and you want to watch our little intro video. We're going to do a little notice and wonder. So check that out, click play on that video, and when you're done, we'll have you click that you're finished watching the video so that we know we can move on. So I'll give you about a minute to do that right now. Okay, we're starting to see people locking in that they have finished watching. I see some check boxes or check marks coming up in the chat window as well. So we'll give you another 5 or 10 seconds here, and then we'll get ready to move on here. Awesome. So again, for those who are late to join us, getting into the Game Show is a great idea, so I've posted those instructions into the chat box as well. You can join us at any time. You can do this in a new tab in your browser if you don't have a smartphone available, and you still sort of get this interactive opportunity throughout this webinar. All right, so it looks like most of us are all done. I'm going to go ahead and end that question, and I'm going to get us and load onto the screen an image, and I'm going to do this in the webinar screen as well. And I want you to, if you're in the Game Show, to type in something you notice or wonder. You can do the same thing in the chat box if you're not in the Game Show. So you should see up on the screen a rectangular box of Krispy Kreme donuts, and it's not just a few. It looks like a lot. So take a moment, type your noticings and your wonderings into the Game Show and or the chat box, and then we will narrow down to a question and start exploring. All right, Renee has given us our first wonder, how big the box is. Emily's saying, how many people would it take to eat all of those donuts? That, you know what, if it's me and I'm really hungry, it might not take too many. It might just be one of me. What the dimensions of the box are by Marie. We've got quite a few coming in through the knowledge chat window as well. How big is each donut? Interesting wonder, because I often have students say that they kind of look like Cheerios. So is it just an optical illusion where, you know, maybe this is just a regular box of donuts and there's just a bunch of Cheerios placed in them? So interesting. How much does it weigh? How many grams of fat I see? All kinds of wonderful things. So I'm going to end the notice and wonder on the knowledge hook window, And we can see quite a few others as well. We see someone has noticed an array that helps them see that there's more than 100 donuts. Someone's wondering if there's more than one level. And we see someone with how much does it cost, how many calories are in one donut. So lots and lots of really interesting pieces here. So I think, you know what, the first question I'd like to start with is how many donuts do you think there are in this box? So if you're in the knowledge hook window, you should see a text box right on your device that you can type in the number of donuts you believe there are in there. And actually, I'm encouraging you, if you have your knowledge hook window open, to upload a photo of your thinking. So if you're jotting down on paper, if you're using a digital manipulative, whatever it is you might be doing, feel free to upload an image of your thinking. It would be wonderful if I could share that out into our screen and into our presentation. So I'll just be copying and pasting them right into our slide deck here. Kit's asking, how come the box isn't bending in the middle? Interesting. Is it being supported by something? Awesome questions. Give you a little bit of time here with your prediction, and then we'll share them out. Feel free to share them out in the chat box as well.
Kyle, I just want to remind you, when you move from slide to slide, to just do slowly, because it takes a while for the slide to actually show up. And so just take your time when you move from slide to slide. Thanks.
Perfect, thank you. Okay, we've got our first few predictions into the chat window. We have 500 by Allison. I see, actually, now we have two Allisons. It looks like Allison F is saying 625. Margot's got 300. So it'll be interesting to see some of our other responses here through the knowledge hook window. We've got Jackie at 800. Allison, wow, we have lots of Allisons tonight. Allison C is at 700. I hope maybe it's 700 factorial. Yikes, I see an exclamation point there. That'd get really out of control real fast. All right, awesome stuff. So I see we have quite a few locked in for our knowledge hook predictions. Let's see what we've got here. We've got quite a few here. Looks like our range is from 250 on the low. No, 200 is our low. And it looks like 900 is our high. Lots in the 600s and 700s. Interesting stuff. So lots and lots of up for us to work with. No uploaded pictures yet. So hoping to see some of those as we go along. So here's what I'm going to do. I'm going to, up on your screen as well as on your knowledge hook window, I'm going to give you a little bit of information here to work with. And there it is. Up on your screen, you should see some dimensions. I'm going to post in those knowledge hook instructions again into the chat window. And I'm going to give you folks some time to update your prediction. And this time, really encouraging you, try to think outside the box a little bit. How might you be able to show your understanding of multiplication? The standard algorithm is definitely an acceptable strategy. I wonder if there's another strategy you might want to explore to see if we can show some conceptual understanding. So we'll give you a little bit of time here, and then we'll share those out. For those interested in uploading a solution, once you input your answer and press submit, you should see a pop-up that will say, thank you for submitting. If you click that OK, you should then see the upload solution button. So if you haven't seen it yet, you might just have to click that pop-up away, and then you should see it up on your screen. And up on the screen, I've also put in the chat box a link to Number Pieces, which is a free web-based app. You can also get it on the App Store. It is free from the Math Learning Center. If you're searching for it, make sure you're spelling Center US spelling, ER. And that is an excellent app to be able to manipulate with base 10 blocks. I see some thinking showed up on the screen here. We have 32 by 20, so 32 groups of 20, or 20 groups of 32, and then 32 times 5, and then add those together. Awesome. We have kids thinking there's 2 levels, so interesting here. So going to find the answer for 1 level, and then doubling that. Nice. Ooh, interesting. Renee says 4 25s make 100, and if I skip count, there's 8 4s and 32. Very cool thinking as well. Awesome stuff. And then Christine has a nice strategy here as well. 20 by 30, then 5 by 2, 20 by 2, and 30 by 5 with a total sum of 800. So using some partial products there. Awesome to see all of these different solutions. I'm going to end the question here and see we actually do have an uploaded photo, so I'm going to pull that up on my screen here. Oh, we've got 2, so I'm going to share both of those up on our screen share. Here's one of the strategies that'll pull up on the screen, and I'm just going to look to Michelle to see if this is actually updating on your end. Can you see that strategy there, Michelle?
Yes, it's there on the screen. Perfect.
Excellent, excellent. Okay, so that one's up there. Nice job. Awesome strategy here. Looks like friendly numbers being 25, which is really cool. Here's another interesting strategy I see. I'm just going to make that a little larger as well. So here's a really cool one as well by doing a lot like what I believe Christine had done in the chat window by breaking it up into 25 into 20 and 5 and 32 into 30 plus 2, and then finding the using an open area model in order to find the solution there as well. So awesome stuff. Here's another one that just popped in as well. This is all through that Knowledge Hook screen. So if you want to participate in the fun and share some of your thinking, this is definitely the way to do it. Awesome job. And 800 is the answer. However, really, I've only given you a little bit of this information. So I'm wondering here, I'm going to put up on the screen, you should see a quick strategy being popped up on the screen for you in the Knowledge Hook window. Up on your screen through the webinar, you should start seeing this as well. Basically, using the strategy that there's 4 25s in 100, we can use 100 flaps in order to do some of this work. So if there's 4 25s in 100, I could go to my base 10 blocks and I can start doing a little bit of work here and say, well, 400 flaps would give me actually 16 25s. And if I continue to build upwards, I can see 32 groups of 25 is actually just 8 100 flaps. So we can start fairly simple, or we can get fairly complex as well by doing some other strategies like using base 10 blocks. So for example, if I use base 10 blocks, what I can see is 32 broken up into 3 10 rods plus 2 units. And our 25 donuts are broken up into 2 10 rods and 5 units. And then we can create an array with our base 10 blocks. So that might start with using our 100 flaps. And I'm just going to jump to show all of our 100 flaps here. So you can see very quickly that 30 by 20 gives us 600 flaps. I can then go ahead and start multiplying out my 10 rods with my 2 units, and I'll find that I have 4 10 rods resulting. Something similar happening down below as well with our 10 rods. So 3 10 rods by 5, that will give us 15 10 rods. And then finally, our 5 units by 2 units to give us a total of 10 ones as well. So we can see that these base 10 blocks can be very helpful in order to show our thinking. And in our last session, I actually revealed a Japanese multiplication method. So I'm just going to quickly share that this base 10 model that we see on the screen is almost identical to this Japanese method for multiplication, or stick math, simply by spreading out your base 10 blocks and then tilting them on their side. You'll notice that all the intersecting points are simply replacements for the base 10 blocks. So up in the far left, we can see all of our 100 flaps. We have 19 10 rods, and we have 10 units. So again, just one other strategy that might be useful as we approach our division this evening. And some might recognize the Japanese method more like so, or possibly even more like this, where they just show the sticks and you just count out your intersecting points. So lots of different strategies. And then finally, the base 10 block strategy, when we actually take our base 10 blocks and represent them as an area model, we're actually seeing the birth of the standard algorithm. So we looked at this last session, but I wanted to take an opportunity just to really quickly highlight that when we multiply out using the standard algorithm, even though I'm doing it slightly backwards here, I guess completely backwards to the standard algorithm, here I'm multiplying my tens columns first, so my 30 by 20. You can see that visually. We then move on to 20 times 2. That gives us 40. We then have 30 by 5, which is 150. And finally, 5 times 2, or 2 times 5, which gives us 10. So we can see that the standard algorithm actually exists in all of these representations that we're seeing that have led up to this point. So that's just a quick little way that we can recap some of our multiplication strategies from last time. But here's my real problem that I have for you. Here's the deal, and I'm going to push a new question to your screen on Knowledge Hook. On the box, there's actually an image that shows this guy right here. So what I want you to do is think about, what does this actually mean? Because we think there's 800 here, but this box is saying double 100 dozen. So how many donuts should be in the box total? There's a question up in Knowledge Hook for you. I see we've got quite a few people in the Knowledge Hook now, so hopefully you can participate there. If you're not, feel free to chat in the chat box with us. I'll give you a minute or so here to think about, what does double 100 dozen mean? And then I want you to think about, what does that mean when we think about the box and how many layers of donuts there might be? Awesome job. So we're seeing it in our chat box here. Natasha's saying 200 dozen. Sarah's saying the same thing, or 200 groups of 12s. And in our Knowledge Hook window here, we've got multiple choice up. We have 2 times 100, 240, 2400, 200, or 1200. So I'm going to go ahead and end that now and get us moving along and on to our next question, an extension on the previous. Just asking ourselves to think about how many layers would be in this box, because you are right, my friends, there are 2,400 donuts in this particular box, despite the fact that I gave you dimensions that yielded 800. So at this point, I typically have my students discussing why that might be. And what we find out very quickly is that this must be a box with more than one layer. Now, the math I'm going to ask you to do here is not all that tricky, but the intent is to start with a very low floor. And this is one way that we can do that. So in order for us to start with a low floor, I'm going to have you think for a second, if you are a student who isn't strong with the idea of division, what might they do in order to determine how many layers of donuts there are? So I'm going to pull up that image on your screen. And it should be up on your screen now. And it's in the knowledge hook window as well. So how many layers of 800 donuts are there? And I really want you to think about how might I show this and what does it look like. So I'm going to encourage our knowledge hook friends to share out their thinking so we can bring them up on the screen, share some of your wonderful math work here on a Tuesday after the long weekend. And we'll give you a little bit of time to think that one through. Awesome stuff. I'm starting to see those solutions flying in. We've got a lot of people talking about repeated subtraction, repeated addition. We have Lisa knows that 8 times 3 and then adding the zeros afterwards, using a little bit of her math facts and some of her mental math strategies. So lots and lots of ideas. I see some solutions coming through in Knowledge Hook as well. Just as a heads up, when I end the question, you still have the opportunity to upload your solution. So don't panic if I end the question and you're still working on yours, you still can upload them and it will add it to the queue as I go through them. So no panic there. Awesome. So Christine's asking, how many layers of 800 would make 2,400 donuts total? And that is true. So how do we go about finding that piece? I'm pretty confident most of us are going to be comfortable with the fact that there are 3 layers. Nicely done for those who shared that out in Knowledge Hook. I see some solutions coming in. So let me pull up a couple. Here's one. I like this strategy here. It looks like someone's using a MacBook as well. I can see that from your picture. Good job. I like my MacBook as well. We see 3/8 equal 24, so 3/800 equals 2,400. And I love this explanation, and I really like to be particular about the language here, because the best part about using those math facts, and going back to, I believe it was Lisa who said, knowing 8 times 3 and then adding the zeros, I like to be very explicit about this adding the zero piece, because there's a lot of conceptual understanding buried there, because if I'm counting 800s, I can still think of it as 8. There are 8 units of 100, and it might even be useful for me to write it out. 8 times 100 plus 8 times 100 plus 8 times 100 gives me 24 times 100, which is 2,400. Like, we don't have to do that, but making sure that students have that deep understanding as to why I can add and subtract zeros is really, really important. And I think that we can really go pretty deeply into some of those conceptual underpinnings behind some of these tricks. Because I'm all for tricks, but only if students are the ones sort of creating those tricks. I don't want to just tell them the trick and not really explain what's going on behind it. I'm hoping that they'll be able to develop them. Here's another one coming in. We've got, I like this, so 800 plus 800 is 1,600. And then 1,600 plus 800 is 2,400. I see that we have 3 800s are circled. Awesome. So there are 3 layers. That's a pretty cool strategy as well. I've got another one here coming in. I just have to hit the rotate button, came in sideways before I pull it in. There we go. Let's do this. Here's another one. All right. I hear children screaming in the background as well, so that's not a good thing, but hopefully that will dissipate in time. Here's another strategy that looks very similar to the previous, so that's pretty awesome. Oh, maybe it's a rewritten strategy. I'm not sure, but looks really good. Awesome. And let's see if we have any others there. Oh, so some interesting work with some of our math facts as well. So here's another nice one. Oh, this one's pretty cool. I'm big on number lines right now, so thanks for sharing this one. We've got 800. We're doing 800 jumps, which is kind of cool to see as well. So awesome work all around. So thanks so much for everyone for sharing the different strategies. And ultimately, what I'm really trying to get at here is I want our students to be able to see that when we go ahead and we look at division, especially early on, and as we move away with more complex numbers, sometimes we forget to come back to what division really is. And I heard a lot of people saying repeated subtraction, I heard repeated addition. So just this idea that I can go ahead and take away 800 from 2400 repeatedly. So I've done this one time, I could do this again, and I can do it a third time. And what I end up getting is the very beginnings of long division. You may or may not see it up on the screen right now, but we have those three layers. We're visually seeing this with context, and we're also seeing an algorithm being developed. It doesn't look exactly like long division yet, and it actually doesn't follow the same principles because long division forces us to take out as many groups as possible right away. So this is we call this a flexible division model, and this actually comes up in the guide to effective instruction. So check that out if you haven't done so. There's not a whole lot of context in the examples we give here in that guide, but hopefully this work will help us address some of that as well. So awesome job so far, my friends. What I'm going to do is I'm going to extend this slightly further. I want to give you an opportunity to play with some other strategies as well. This question is an extension. It just carries on the idea. If your school bought this box of donuts to split between 8 classes, how many would each class get? So I'm going to give you an opportunity. I'm going to pull this up on your Knowledge Hook screen as well and give you an opportunity to work through this problem. I'd love to see some more solutions coming in through the Knowledge Hook Upload Solution button, and I will share them out on the presentation screen. So take a moment, try it out. You can use long division if you'd like, but I wonder if there's another strategy that you might be able to use here. And feel free to show us a strategy you tried that maybe didn't work out for you. It's, the whole idea here is to try to stretch outside your comfort zone a bit and try a new strategy that might help a student who struggles with going right to an algorithm. And we're seeing solutions come in. Feel free to share out in the chat box. Michelle is reminding us, thank you, Michelle, that's a good idea, is using a checkbox is always a nice idea as well in the chat, in the OTF chat. And we'll share out momentarily. All right, great stuff. We've got quite a few who are ready to share out. Feel free to share out in the chat window if you're not a part of the Knowledge Hook. So how many would each class get. I see a couple solutions coming in as well, which is excellent, so we'll be able to share some of those out. At this point, if you're in the knowledge hook window, don't worry too much about what you submit in terms of the number or numerical answer. Just submit something so that you can upload your solution once it's complete, and then that way we'll be able to share out your thinking. Samia is suggesting we determine how many 8s are in 24 and then add the zeros. So again, that's a great suggestion. I'm wondering how we might be able to incorporate some conceptual understanding into that as well. So if I'm a student who's struggling, maybe I know how many 8s are in 24, that's 3, but now how many zeros and why? So if there's 3 8s in 24, there should be 38 in 240, which means 308 in 2400. So helping them kind of make some of those connections is pretty big. Mike's saying each class gets 100 from each row of 800 donuts, so 300 each, which is pretty cool. So by row, I'm assuming like each of those layers, I guess, or I guess horizontal layers, if that makes sense. Awesome thinking as well. I'm going to go ahead and end the question in knowledge hook. Ooh, we have Christine suggesting we partition the box, so thinking fractionally, which is really nice. Awesome job. Lots of people are saying 300. Here's a couple images according to what you folks saw. So I see, oh, a very interesting strategy here. So we're going with 24 by 100. So they're making a new grid, almost like they're rearranging the donuts in their own way. So not sticking to this idea that they have to be organized the way they are currently. I could take them out of the box and I could rearrange them however I want. That's a pretty cool strategy. I really like that. Let's have a look at this one here. We've got 3 layers of 800. I know that 3 times 800 is 2400. So 2400 divided by 8 must be 300. Awesome way to use some of your prior knowledge from that previous question, which is really cool. So you'll notice the numbers I've selected, that was intentional to give students an opportunity to play with these numbers and see how they're related and how numbers and changing where we put the numbers might affect some others. We have a screenshot. That's pretty cool. It looks like we have, is that 2400 flats? 1, 2, 3, 4. Yeah, something along those lines. Very cool. Awesome job there. And we fractionally split those up as well. Sorry, I didn't share it to the screen. There it is. There's the one that I was just referring to. Awesome stuff. And then we have another array as well that I'll share up on the screen. So lots and lots of different strategies here, which is really cool to see, and I really appreciate our friends who have shared their thinking with us up on the screen. So lots and lots of good thinking there. And one of the ones that I thought I would share out with you as well is just this idea that, for example, I could go ahead and if I'm a student, if I really wanted to, I could go and I could basically use repeated subtraction. Just like when we start with division, we're using some repeated subtraction, and I could just give out 8 donuts at a time. So basically take a group of 8 donuts out of the box, give 1 to each class. So I fair share 1 donut for each class. That's 1 group of 8 that's been moved out of the box. Some say, 8 groups of 1. It really doesn't matter. It depends on the context of how you think about it. And I could do this over and over again, but man, oh man, is it going to take me a long time to get to the end, right? So someone else might consider, maybe I take away 10 groups of 8, and now I'm giving 10 donuts to each of the 8 classes. So I take out my 80 donuts, I give 10 to the first class, 10 to the second class, 10 to the third class, and so on. And I do this over and over again. But that's still going to take me quite a while. So maybe what I might want to do is maybe I want to use some larger numbers. It really doesn't matter what number you decide, but for me, I always figure, well, if I'm dividing it by 8 classes, sticking to 8, 80, 800, so multiples of 8, or multiplying 8 by 10 each time and getting larger and larger friendly numbers, things get a little bit easier for me. So if I go to 800, you can see I've taken, and for some students, they might see that I've actually taken out a third of my donuts. I give 100 donuts to the first, 100 to the second, and so on, until I get back, and then I have to do this again and again. And I do some repeated subtraction until I get to this point. And what you'll see is that while, actually let me back it up just slightly. When I get to this point here, when I repeatedly subtract 800 donuts or 100 groups of 8, what I realize is that I, again, get very close to the standard algorithm. The only difference is that I now just have to add up how many groups of 8 I've taken out, which is 300, and I just have to add my little fancy notation up at the top. And now what I have is that flexible division algorithm once again working for me. So again, not the only way. I think all the strategies that were shown tonight were awesome, and I love when I see all these different ways of thinking. I heard someone also say, like, could we like divide up, you know, the layers? Like, for example, I might want to, you know, divide up my layers. Notice that if I just divide each layer in halves, that's not going to do it. But if I eventually get to a point where I divide up all the layers by 8 and give 100 from each layer, which I believe was mentioned earlier in the chat, what we end up with is an opportunity for every class to get 300 donuts. So again, just some thinking around division and around, I guess, where we might want to start with division, at least when we're heading towards larger numbers and using long division. It might be useful for us to use that repeated subtraction and lead ourselves slowly towards an algorithm, rather than having students go straight for long division where they have to select the largest number of groups that they can take out of each divisor. So with that, we're going to move on here, and we're going to dive right into our progression. I wanted to get us warmed up for the evening, and I think we've done that quite well. If you're from primary and you're thinking that this is too many donuts, you might want to go ahead and use maybe a smaller number of donuts. So I have a smaller set of images that just have our regular Krispy Kreme donut size. For younger students, they might not know how many donuts come standard in a donut box, so this can be a pretty interesting task. There's all kinds of images that we have there, and students can still have just as much fun and approach some of this multiplicative thinking and so on. So with that task, you know, it just makes it a little more manageable. Or if you have students in grade 5 who really aren't comfortable with larger numbers yet, maybe you want to use some slightly modified friendly numbers like dimensions of 30 by 20 donuts and so on. So lots of that for you. I'll share out the link to this task at the end of the webinar. And then there's also some extensions to this task as well. So how many calories in the entire box, how long would it take you to jog, all kinds of stuff that are related. So if you're into proportional reasoning, getting into grade 6, 7, and 8, this task could be a really cool way to start some of those bigger ideas. So what I want to do now is I want to turn the attention here to where division begins. So I'm going to just slide on down to our grade 2 number sense and numeration strand, and we're going to pop up this particular expectation, and I'm going to have you go ahead and draw yourself a picture. We're not going to share this one out, but I'll have you draw this picture and just sort of think think through how would a student go ahead and fair share 12 carrot sticks equally among 4 friends. So if you're a student who does not know their math facts yet, because we're still in grade 2, we're just starting to get into this unitizing, all the grouping, and all this wonderful multiplicative thinking, go ahead and get that set up, and then we'll start extending this, and we'll talk about 2 types of division that you may or may not be aware are lurking about when we're introducing division to our students. Okay, so let's have a look here. I think most of us are fairly comfortable with this idea. Where division sort of begins, or at least becomes pretty explicit, is this idea of fair sharing. So if I'm taking these carrot sticks and I start fair sharing them to each of my friends, and I take 1, I'm basically repeatedly subtracting 1 each time. You'll notice that we've kind of, we've lowered the floor from our initial problem with all those donuts. Before we were, repeatedly subtracting 8 or 800 or whatever it might have been, these large numbers. But typically when you're fair sharing as a child, you're just fair sharing 1 at a time. So you're repeatedly subtracting each time. And what you end up with in this particular case is a scenario like so. So you end up realizing that, you know what, my 4 friends will get 3 each, and it looks something like this. Now, what I wanted to do is take a little bit of time to explore into grade 3 and grade 4, where we start upping the ante a little bit. Because what we end up doing is we end up working with some slightly larger numbers, and things get pretty complicated pretty fast. So what I want to do is I want to share a problem that actually comes from Alex Lawson's work in her What to Look For book, and this is one of actually based on one of the videos out of that book series, and it's credited at the bottom here. Basically, it's a story where the student buys 15 goldfish, and the student's asked to put them in jars with 3 in each jar. How many jars will you need? And what you'll find here is that you actually have the opposite of what we did in the last case. Before, I knew how many people there were. And in this particular problem, we're telling you how many people, or in this case, how many jars there are, and, we're telling you how many go in each jar. So in the last question with our carrot sticks, that would be like saying, I have to give, out of these 12 carrots, I have to give everyone 3 carrot sticks each. How many people are there? There's actually 2 different types of division based on the context of the problem. But if we only give students 15 divided by 3, we don't really see that complexity. So as soon as the context is added, we've actually added something that's fairly complex for students to have to think through and reason through. So for this particular student, it's likely that they'll probably take these cubes and organize them in groups of 3, and then once I have them in groups of 3, I go ahead and I count how many groups there are. When I do this, what I end up getting is an opportunity. So ultimately, I've got these 3 groups, and oftentimes they don't even look as neat as this, right? Students will just group them into piles, and then they have to sometimes even have to count each pile again to make sure there's 3 in each, because they aren't necessarily subitizing those 3 in each group, or maybe they're having trouble skip counting by 3. So there's a lot of stuff going on here when we introduce this idea, especially from a conceptual standpoint. So when I'm looking at these groups, what I wanted to mention here as we explore these 2 types of division is just the idea that at some point in the 3rd grade, not right away, but ultimately at some point, we are asked in the curriculum to start looking at arrays. And I mentioned this back in the multiplication session, how important I believe arrays are. I believe it's really important for division as well. Again, we're not starting with arrays. Once students are really comfortable with grouping and sharing out into these different groups, sharing them into groups evenly, then we might have them take these 3 groups and create an array with them. So you'll notice before we already had 3 in each group. Now all I'm seeing them is just organized in an array. And some students might, decide to have a, to flip the orientation here and have 3 rows and 5 columns instead. But what I want to get at here is what's actually happening in this particular problem, because this is actually called a quotative division problem. And you encounter a quotative division problem when you know how many items are in each group and you need to determine how many groups there will be. All right, so this is a quotative problem. This is a situation where it's really easy to use repeated subtraction in order to find this answer, because I know that if there's 3 in each of these groups, I simply take away 3 each time and I just place them separate from one another. And now I have 5 groups of 3 when I go ahead and I count them out afterwards. So really, really important stuff. And I see Krista's advertising Kathy Fosno's book, not a book study. I think it's actually tonight. So we're competing with them tonight. I listened last week and it was fabulous. So definitely give that a listen. It will be available tomorrow on, I think it's voiced Ed Radio. So definitely check that out. Worth the listen. But back to our quotative here. This scenario, again, I'm just going to give you a little visual to think about. This is where the number in each group is known, but the number of groups is unknown. So again, this is opposite to our carrot stick problem. What I want you to do is take a moment in the chat box, and I'd like you to look at this scenario here with our 15 goldfish. I want to maintain that 15 goldfish, and I want you to reword the remaining part. So I buy 15 goldfish. How could I reword the rest of the problem to give us the other type of division, which we are going to be calling partitive in just a moment. So I'll give you a moment there to try that out again. We have 15 goldfish. What is the other way that I could word this problem in order to give us our second type of division? Nicely done. So Sarah's our first to respond here. Just rewording this question slightly gives us a different way or a different perspective for this problem. So I have 5 jars. How many are going to go into each jar? So when we look at quotative, some call it, I believe, measurement division. So it's this idea that you could take those 3s and line them up, one next to the other, and you'll get a full measure of 15 or a whole 15. This other way to ask this question is called partitive division. And when we do this, partitive is when we don't know the number in each group. So that would be similar to our carrot stick problem. So why am I saying this? Why am I telling you this? Both of these types of division, I think, are really important for us as educators to know. I'm not certain whether I believe students need to know the names of the 2. Maybe having an anchor chart to show that there's 2 types and having two examples is probably really important to have that discussion. But for me as the educator, I need to know that there's 2 to ensure that I'm asking both. Oftentimes as educators, we get stuck in these routines, and if I'm asking quotative division problems all the time or partitive division problems all the time, that really will hinder my ability to ensure my students are fully prepared and getting a well-rounded understanding of the content. Now, as we move on, I'm going to take a moment here and jump into grade 4, and you'll see that in grade 4, things start to get a little more complex. Now, we're still using mental strategies up to 9 times 9 and 81 divided by 9, but you'll notice that we're now getting to a point where we're dividing 2-digit whole numbers by 1-digit whole numbers using a variety of tools, noting that concrete materials is one, so physically doing this stuff is really important. Drawing them out is really important. And then we talk about student-generated algorithms. Above, with multiplication, they talk about student-generated and standard algorithms. So there's a distinction there. In grade 4, we're not really asking students to come up with long division or anything like that, but to be able to do something like the flexible division algorithm, because they understand the idea of repeated subtraction, is probably a great idea. So if we talk a little bit about quotative and partitive again, if I was to take something like 56 divided by 8, right away I'm eliminating context, and I haven't given students an opportunity to actually think about whether this is partitive or quotative, right? So how they go about this problem will help define what kind of context, or I guess what sort of division problem they're actually doing when they approach it. So for example, if a student was to take groups of 8, so I take 8 tiles and I put them into a group, what I'm basically getting at is I'm getting at quotative division, because I took 8 in each group and I needed to count how many groups there were. So if that's the strategy the student's always using, then they haven't really been exposed enough to partitive addition, where partitive division would look like coming out with 8 groups. They might not necessarily draw out the 8 groups, but ultimately they would have to start fair sharing, either one or maybe they fair share 2 at a time, or however they choose to fair share, and what you're going to find is the exact opposite. So now, partitive, we're seeing that there's 8 groups with 7 in each group. So I think it's really important that we see both of those things, because that's a fairly important piece of the puzzle. Now, as we go to larger numbers, the same can be true. If we were to look at something like, something like 120 divided by 8, here's what it would look like quotatively. Here's what it would look like partitively. But the part that I really want to express here and really communicate is the idea that both quotative and partitive can be represented as the same array. So here's the partitive array. Here's what the quotative array would look like. And ultimately, they're the same exact array. It's just how we group these items. So I think it's really, for me anyway, it's for something that's really important for me to note, that when we get to dividing and we're using arrays, arrays can help us find the answer faster, but it's very difficult if we jump to the array too quickly. So doing a lot of that fair sharing and a lot of that partitive quotative practice is going to be really important if we want students to understand this deeply. So here's kind of what that looks like overlapped in front of each other. But what I'd like to share with you now is just this idea that we can also do a lot of this work with base 10 blocks. So as the numbers get larger, what we want to do is we want to start using base 10 blocks to make our lives easier. So for 120 divided by 12, for example, I could take 100 flat and 2 10 rods and ultimately try to determine what the other factor is. So now what we're looking at is we're taking these arrays and we're trying to find the dimensions. So here I've got 120. I know that one of the dimensions of my rectangle or my array is 12, which you can see outlined in blue. And what I'm looking for is the dimension of, or the missing dimension in this particular case, which you can see pretty quickly is a 10 rod. So my answer would be 10. So what I'm going to have you folks do is we're going to be putting up a question on your screen in just a second in Knowledge Hub. I'm going to give you an opportunity to use some base 10 blocks in order to do some of this work. And I'm going to again share the number pieces interactive tool in the chat window. So that should be up there for you right now. And I'm going to go ahead and go on to the next question, which is 112 divided by 8. And what we want you to do is take some time, whether you're drawing this out on paper. I would never have students use base 10 blocks drawing them out until they've done this physically. Today, I'm having you skip that with base 10 blocks and having you do it digitally. So just keep that in mind that, I wouldn't really start with this digital manipulative. I would start with real base 10 blocks, make sure they're really comfortable, and then we would move towards something digital and then maybe drawing. So I'm going to give you a moment there to head to the Number Pieces web tool. You might also have it on your iPad. Feel free to use that, and we'll share what that looks like in a moment. As usual, feel free to take screenshots or take photos of your work with your manipulatives and any strategies that you might have used to upload to Knowledge Hub. Yes, folks, it is definitely a bit tricky. So what I'm going to do up on the screen is I'm also going to model this one as well as we go. So feel free to have a tab open with your number pieces. I'm going to go ahead and show you what 112 looks like with base 10 blocks. So here I've got 100 flat, I've got a 10 rod, and I've got my 2 units. So the beauty of base 10 blocks is you're literally looking at place value. So I see a 1 for the hundreds, a 1 for the tens, and 2 for the 2 units. It's wonderful. And when I'm dividing by 8, what I'm doing is I'm trying to create a rectangle that has a dimension of 8 by some other length. Right? When we're looking at this array, I basically need to get my dimension down to 8. So if I'm dividing anything by a number less than 10, then I know that this 100 flat is going to have to get busted up. And when I bust up that 100 flat, and if I show my 8 pieces here like I'm doing up on the screen, you can see that I've got a dimension of 8, and now I've got to take my other pieces here. I've got 3 10 rods and 2 units that need to fit in somehow. And you'll notice they are not fitting in right here like so. So even if I try to bring them to the other side, they're not fitting in very nicely. So what I'm going to have to do is I'm going to have to find a way to fill in these gaps. Right? No matter how I rearrange them. So I'm going to have to go ahead and start breaking down my 10 rods, and I'm going to have to start fair sharing these units. And when I do that, I end up with the following. And you'll see that what is outlined is our missing answer, which is 42. So if we go ahead and we break down our base 10 blocks, the key here is that if I'm taking a number and I'm dividing it by 8, one of my dimensions is 8. So I'm going to have to create a rectangle with one of my width or length is 8, and I'm basically going to use trial and error by rearranging my manipulatives in order to determine what the missing dimension is. All right, so I could do this by going all the way down to units, right, 112 units, and then fair sharing out all these 112 units. That would take forever. The beauty of the Number Pieces app, which is also on the iPad, is that you can actually, and it looks like Christine's discovered it, you can actually decompose and recompose your 100 flats and 10 rods, which is beautiful. This is definitely challenging. It's a challenging way to approach division because division is hard. And for me, the reason I think it's so important is because all the way into grade 10, and I'm going to show you an example of this later, when we factor in algebra, you are ultimately doing what we just did, but it's actually easier in grade 10. But the grade 10s find it very difficult. And the reason why is because they really don't have a good understanding of what division really is. So this is a really important strategy, and again, I think it's really important to allow students to play with these ideas so that they can really work on their strategic competence, because this is more than just a procedure. I can learn the procedure. I was that kid in school who knew the procedures, but it wasn't very helpful to me in the long run because I didn't really know what I was doing. So what we're going to do tonight is really try to build a little bit of understanding, and I will be sharing out some resources tonight as well, and I'll also have a blog post summary of this coming up shortly in the near future for you as well. So let's go ahead and let's try another one here. Let's go to, it looks like I've got a couple solutions. So here's a few of the solutions that came through with Knowledge Hub, which is really cool to see. Again, oh, cool. So you're using kind of a little bit of a visual strategy as well. Awesome. Great stuff. How about this one? Let's go ahead and try 189 divided by 9. So we first want to begin by getting 189 taken care of, and then we're going to try to get our array going. So here we go. I'm going to share this out on your Knowledge Hub screen for those who are in Knowledge Hub, and for everybody else, feel free to use your widget and share it in the chat box. A quick tip I'm going to mention again is that we are dividing by 9, so that means the dimensions of my rectangle, I need one dimension, which is 9. A base 10 flat for a 100 flat is 10 by 10, so you know that has no real interest in being in this particular area because it's actually not going to fit. So we're definitely going to have to bust that guy up. So you're going to have to bust them up and do some rearranging. See if you can do it. I would try it with the digital app. It's very difficult to draw out, especially if you've never done it before. Again, using the physical manipulatives is much, much more useful and more user-friendly as well when you're starting. Now, if you're a student doing this, at first it's going to be straight up trial and error, and I'm going to argue that you folks likely are students in this particular case because we were not taught, at least I wasn't taught, and most people I've talked to were not taught this way either. So it's like we're doing this brand new, and it sort of makes you feel kind of silly because you're like, I know how to divide, but how come I don't know how to do this? And it seems very challenging. What you'll find students doing as they start arranging, they're going to start seeing that certain characteristics are required, and they're going to start doing some of these decomposing strategies in their mind to try to visualize, like, where am I going to have to put these pieces and how is this going to work? So it really ties into our spatial reasoning pieces as well that we've spoken of quite a few times in the past few OTF Connects that I've worked on. All right, and Emily's asking to reiterate why that 100 flat needs to be broken down, and it's because in this case we're dividing it by a number less than 10. So my base 10 100 flat is a 10 by 10 square, and I know my rectangle is a 9 by something rectangle or square. It could be a square, but it's going to be a 9 by something. So that 100 can't fit in there anyway. So you can definitely, with physical base 10 blocks, you're going to have to actually do a lot of swapping out. There's a lot of value to why you'd want to spend this time as well, because if you think about conversions, when we're converting from centimeters to meters and meters to kilometers, it's exactly what we're doing, but we're doing it all abstractly. We're telling kids that this equals that, but we're not actually experiencing it. So this is a great way to really sort of preempt the metric conversions that we're going to be doing later anyway. So again, trying to show how interconnected the math is. So in this case, if you go ahead and you chop this all up, divide it all up, you're going to end up with 21 groups of 9, which you can see here, this rectangle that was formed. And I'm going to go ahead and end this question and see it. I think we have a solution or two as well. Someone has a screenshot of the number pieces app, which is super cool, awesome to see. Whoops, that didn't work right. Let me do that again. I put it on something else. There we go. So there it is. Look at that. So I am showing my factors explicitly here. This person is not. Definitely a valid strategy. No issues with that whatsoever. So really cool to see you using that app and taking screenshots or photos of it anyway. Here we have another person using a area model. Now, well, I guess it's really just a drawn version of the base 10 model, so awesome stuff. But something to note here is that area models, like we were using earlier with our donut task, they are the same thing as our base 10, except a little bit more flexible. So something to consider. Awesome to see everybody attempting to draw this. It's so much harder to draw it than it is to manipulate. So if you're drawing it, I feel for you. It's definitely much easier to be using the actual manipulator. So really cool, awesome stuff here, friends. We've got another one here for you to try. I'm going to go ahead and jump to, this one's a good one. We're going to go to 221 divided by 13. I'm going to put that up on a knowledge hook screen as well. And there you go. And we want to divide this into either 13 groups, or we want to know how many groups with 13 in each group, quotative or partitive. In this case, it doesn't really matter. In the end, all we want to know is what the other dimension. Now, as you work your way through this one, you can see that 100 flats seem legit here, except if you take a look at my webinar screen here for a moment, when I try to rearrange, you'll notice I'm not getting that perfect rectangle. So again, I'm going to have to divide up at least one of these 100 flats. So I typically, you just want to chop things up slowly but surely. You don't want to get too crazy. If you're using physical base 10 blocks, it's really important that students understand what they're trading in and they do straight trades. They don't just get sloppy with it. It really can get confusing fast. So they have to be very on top of what it is they're trying to swap out. So here I've swapped out a 100 flat for 10 rods. And now I'm going to go ahead and try to build this rectangle by doing a little bit of moving around. So you can see here I took 3 10 rods to fill up that little bottom left corner. I'm like, all right, this is looking pretty good, but I got a big gap going on over here. I take my unit, I put it there, and I go, wait a second, this isn't going to work. So I go and I start swapping out my 10 rods for units, and then I place them in. And then I swap out another 10 rod for units, and I place them in. And eventually I get there, and you'll notice here that I have a nice, beautiful array that works out to be 17 is our missing dimension, or 17 is how many are in 13 groups, or there are 17 groups with 13 in each group, depending on how you look at it. So there are a ton of reasons why I think this is useful. Again, I think we have to really slow down and think here. We started in grade 2 with fair sharing 12 carats, and we've already made it into grade 5 and grade 6 doing some of this pretty heavy lifting, this question in grade 5, where most of us might just jump straight to long division, but we know a lot of students are going to struggle. Students are going to struggle to use these base 10 blocks and to come to an answer. It's not about speed. It's about that strategic competence that they're building that conceptual understanding. This helps them lead to building procedural fluency, because eventually they're going to say, you know what, I don't need to use these base 10 blocks anymore. I can picture what that looks like, and then maybe what I might want to do is maybe I want to move to something like an area model versus using arrays. So I'm going to end this question here. I'm going to see if we have any solutions to share. We do have one, so I'd love to share that out. So awesome job to our friends sharing out solutions. Beautiful. It looks like the candle is burning in that room. It's nice red, kind of orange aura in that room. Awesome stuff. What we're going to do now is I want to take a problem like this one, and I'm going to ask, now we're going to kind of move away, and this isn't my decision. I don't get to decide when we move away from base 10 blocks. It's when students are ready to start drawing it instead of using base 10 blocks. That's when they move there. So it's not like today we're like, okay, no more base 10 blocks. It's students, when they're ready, they're going to start doing it anyway, just like a lot of you are and are submitting their answers through Knowledge Hub. You get the hang of it, you understand it, and then you start to build in some nice and easy strategies using some friendly numbers. So here, I'm going to give you an opportunity to take 195. We're going to have you divide by 15, but I'd like you to break it up. And I've got in the corner there, you can use distributive property as a way to think of this. If I break this up into smaller chunks, I can do ultimately what base 10 blocks do with a little bit less hassle. So we'll give you an opportunity to do this, and then I want to make a connection to grade 9 and 10 algebra. I'm not going to have you do the work, but I do want to show you that there's a lot of value as to why we've done what we've done today. But unfortunately, we're not putting it into full use in Ontario simply because we weren't shown these ways when we were taught. We didn't see them in the faculty, at least in most faculties. And I really do think that if we start shifting in this direction, we'll see a lot more students making a lot more connections into grade 9 and 10 academic and grade 9 and 10 applied when they reach some of these more difficult and abstract concepts. So take a moment, try it out, see if you can come up with a strategy, and then we'll get ready to start wrapping things up. All right, I like some of these strategies I'm seeing here. We've got, all right, Jody's got 150 plus 45, so decomposing 195. And it looks like seeing that 150 and 15, there's definitely a relationship there. And 45 and 15, awesome steps. Some students might choose to do it that way. Some students might see it, maybe they need smaller chunks. It's really up to them, but the beauty is that everybody has an opportunity to break it down based on their own personal preferences and what is a friendly number to them. Awesome stuff. Emily, nice strategy as well, breaking it down. Kind of going about it more multiplicatively, so kind of heading that direction and working your way towards 195, which is really cool as well. Awesome stuff. Lots and lots of great ideas here, friends. I see a few people on Knowledge Hub coming down the stretch. Here's how some students might go about this. Some students might, start taking away 15 at a time, right? They might go ahead and subtract 15 and end up with 180 left, and they just continually, repeatedly subtract, right? It's going to take a while, but it'll get there. And they're going to end up with something like this. It'll take a long time, but they end up with 13 15s. But what we're hoping to see is students doing something like we just saw here, where maybe some students notice that there's a relationship with the 150. And if they subtract 3 15s, we're down to 150, so there's that 45s out of the way. And now we're down to 150. And I know that there's 10 15s and 150, and we're good to go. right? So some students might approach this in slightly different ways, and ultimately they're now able, or at least more willing and able, or ready and able to attack some of these problems a little bit more intuitively. So thanks to those who participated in the knowledge hook. What I'm going to do is I want to just jump straight to a little bit of grade 9 and 10 here. Here I'm going to go right to a grade 10, not to jump to confusion, but I do want to really reiterate how important it is, because what you may see is up on the screen is a bunch of algebra that you may or may not remember from high school. If you're not teaching in high school, you may not have seen this for quite some time. But we could take simple problems like the following, and we can use the same strategies to get there. So for example, if I have a pool with a width of 3 meters and an area of 12 times a number, what is the length? What we can do is we can set this up and know, okay, well, it's 12 times some number. We can call that number x or whatever variable you want, and basically use some of the same strategies where if we say, okay, well, let's figure out what's x times 3? Well, there would be like 3 x's there, right? There would be 3 x's. So those 3 x's, if I take them away from the 12 x's I originally had, I'm at 9 x's. So I'm using that same repeated subtraction strategy. And I should also mention, too, that these algebra tiles we're looking at are the same as base 10 blocks, except we don't know what base. You can call them base x blocks if you want, because I don't know what x is. X is some unknown number. So you'll notice it's not as long as 10 units because they just wanted to pick some arbitrary length. We don't know what x is. So that's the abstract part of algebra. If I do this again, if I put another x down and go, okay, well, now I'm going to have to subtract another 3 x's, and that leaves me with 6 x's. Well, you can kind of see where this pattern's heading here, right? If I take away another 3 x's, I'm left with 3 x's. Hey, wait a second. In no time, I can see that my answer, my length, must be 4 x's long. So if this had context, maybe I'm using a rake, maybe I'm using a pool noodle, whatever it is that you're using, I have 4 of those rakes or 4 of those pool noodles to measure out the length of that pool. And again, we're going backwards using some division in order to get there. Now the same is true if we get to something a little more complex. Now this isn't, again, to scare you. See this 3x squared plus 11x plus 6. That's the area of this pool. But when I look at an x squared, what I picture in my mind is the base 10 flat. Why? Because the base 10 flat is a 10 squared flat. We don't call it that, but maybe we should, because 100 flat is 10 by 10, and x flat is an x by x. So I have 3 x flats, or x squareds. I also have 11 x's. There's my 11 x's. And I also have 6 units. And what I want to do is basically take these units, just like we did with the base 10 blocks, where I want to find a rectangle. Here I haven't given you any dimensions. You just have to take these and make them into a rectangle. So I could try my best. I try it like that first. Like, man, that doesn't work. This isn't very fun at all. What if I tried it like that? It's not going to work either. What if I tried it like, oh, wait a second. Okay, it's nice when I have that pool in the background, right, to help me trace it out a little bit. Okay, that makes it a little easier. All right, where am I going to put these 2 x's? Oh, that goes there. Okay. This one goes there. And then, you know what? What do you know? I've got myself my rectangle, and I also have my factored quadratic, which is the same as dividing with base 10 blocks. I would argue that grade 5 division of base 10 blocks is harder than grade 10 academic factoring of trinomials if we're using these visuals and these concrete manipulatives, because this is what I end up with here. I end up with a length of x plus 3, or picture 10 plus 3, or 13 if x is 10, and 3x's plus 2, or 32 if x is equal to 10. We just don't know what x is. X could be any number, right? So the idea here is not to confuse you or to complicate things, but to show you that using concrete manipulatives to start building that conceptual understanding and working our way to the abstract is really important. And we do this through the concreteness fading model. So today, we did this in a number of ways, right? We started with concrete. We got you drawing. A lot of people naturally went there. And then eventually we get to symbolic. Unfortunately, it's backwards. A lot of times students are using symbolic notation well before they ever understand what they're doing with it. Another visual that you might have seen tonight would be something like this, using your base 10 blocks, then going to an area model, and then using some sort of symbols. So there's all kinds of different reasons why concreteness fading is so important. Because even as we get into grade 9 and 10, we can really help students better understand what it is they're trying to accomplish and what they're trying to learn. So we're getting cut off here. It's about 9 o'clock, so I wanted to give you a little summary of what we're trying to achieve today. Basically, as I do every time, I want to start with a task. I want to make it contextual, visual, and concrete. I want to let you use inquiry. I want you to build conceptual understanding, make some connections to your prior knowledge, and extend it and consolidate towards those procedural fluency and algorithms. So with that, I'm going to hand it back to Michelle. We've got a bunch of links that are going to go on the link page, on the resource page. You're always more than welcome to contact me through my website, tapintoteamminds.com. And I look forward to speaking with you on Twitter, @MathletePierce. Thanks so much for joining me tonight. And I'm really looking forward to the next time we get to do some math on an OTF Connect session together.
Thanks, Kyle. Thank you so much for another particularly exciting and interactive session, and for keeping cool under pressure. We certainly tested the limit of Blackboard tonight. It was an extremely positive session, despite some small technical difficulties early on, and despite the slight visual delays due to application sharing. But I think that it actually worked quite well. I'm certainly glad we made it without crashing Blackboard. And again, our apologies everyone for the small technical difficulties. I also want to thank all of you for sharing your ideas and experience along the entire session. There's never as much participation as in Kyle's session. I think that's really unbelievable. I really loved seeing all your donuts diagram fly on the screen throughout the session. And obviously, hats off to Kyle for juggling all these tasks in real time. I'm always incredibly impressed. Kyle's mentioned, we have a number of links, and they will be provided to you tomorrow. But I'm just pasting here in the chat box 4 main links that Kyle has provided, but you will receive everything tomorrow by email, so you should not worry about it. I'm just going to go back now to my slides, and I just want to talk to you about upcoming sessions. We have a number of particularly interesting sessions related to mathematics in the coming days. Tomorrow, a presentation by Tina Zita titled "Sparking Rich Dialogue with Digital Provocations in Math." I don't know exactly what it's about, but you guys probably do. On April 20, Laura Ginny Newman will be back for the second part of her presentation on critical thinking in the primary math classroom, a session that you should not miss if you enjoyed part 1. I think it was earlier in March. On April 26, a presentation by Jennifer Evans and Erin Clisby titled "Tripping Over Math in Kindergarten." Jennifer and Erin are new to OTF Connects. It will be their very first session. I warmly invite you to participate, and I certainly look forward to it myself. And finally, on May 1st, our first French session of the season by Susan Forrester and Jen Rochel. We only have a handful of sessions in French, so if you know French teachers, please forward them the invitation. We would love to get lots of participants for that session. I'm just going to provide you quickly with the links to our calendar and to our past webinars. I'm going to put that into into the chat box if you want to explore yourself our calendar and see what's coming up. And I also would like to tell you about another opportunity provided by OTF and the Ministry of Education. If you are a qualified teacher and have completed an additional qualification course in math, technology, or kindergarten, you may be eligible for a $450 subsidy. And I'm going to paste the link in the chat box as well, so that you can apply for that subsidy. Sorry. Yeah, okay, that's the right slide. Sorry about that. As you know, we always value your feedback, and that's very important to us. So when quitting Blackboard, you will be presented with an opportunity to give us your feedback on tonight's session. The survey only takes a few minutes. If you have the time to do it tonight, that would be great. Upon completing the survey, you will be redirected as well to another page, allowing you to enter your name, and you will then receive a certificate of participation to this training session that you will be able to add to your professional learning resume. If you don't have the time to do this tonight, don't worry, because that will be part of the email we send you tomorrow morning as well. But I'm going to provide you with the links just in case you want to do that tonight. Here are the links, but you should be redirected, as I said, when you are quitting Blackboard. And I also would like to provide you with the link to the resource page for Carl's session tonight. It will be live in an hour or two, but for sure by tomorrow morning I will have everything uploaded to the OTF website. So that's it. We are about to end the session. I just want to invite you to follow OTF on social media as well as on the OTF website. And I want to thank you all again for your participation tonight, and hope to see you soon on OTF Connects again. Bonne fin de soirée à tous et à toutes. Nous espérons vous revoir très bientôt sur OTF Connects. Merci beaucoup.